Okay, let me introduce my colleague Glenn Tong. He is in charge of product lead of concrete company in Netherlands. So please welcome Glenn Tong. Mr. Glenn.
Hello everyone, like Dr. said, my name is Glenn Tong. I work at Concrete for almost 4 years. I started as an intern. After that I started assembling machines, so building them. After 1.5 years I started doing commissioning, so that means I'm integrating software to the machine. So in the machine we have the PLC, and we have the drives for the motors. What I do is I integrate the software and I set the parameters. I also do the commissioning of machines, so that is basically the factory acceptance test. When the machine is finished from the production, it also needs to go through a whole process in order for it to be accepted for clients. Today I'm going to teach you a little bit about what binder jetting is and what we do as a company for binder jetting. I have a small presentation, a little bit more for beginners, and the one afterwards is a bit more in-depth about the machine that we are currently having here. So, what is binder jetting? Binder jetting is a type of 3D printing where you use a liquid binding agent. So, it is basically like sort of glue. You have a fluid supply where you put in your glue, and you have your powder. And what you do is you spray a pattern of glue on the powder, and then you spread another layer of powder over it, and then you spray again. So what happens is, in the end, you have a lot of layers with patterns, and that will create a 3D model. So the materials that we use as concrete, what we know that works, are metals. So think about copper, stainless steel, ceramics. We're still experimenting with this. Sand. Sand is very interesting as a washout material. Washout is for like molds. We also use silicon carbide. Silicon carbide is one of the hardest materials in the world. The interesting thing about silicon carbide for 3D printing is that we can make objects that you cannot make with a milling machine. Also, milling machines are 2-3 million euros, very expensive, and it takes normally 2-3 weeks for one object to get out. And with a concrete 3D printer, we can have in 2-3 days multiple objects. So it's very cost efficient as well. And stone-like materials. What we have here today is we have a lot of stone-like materials. The interesting thing about stone-like materials is that it's used a lot of times for structures. So the advantages of 3D printers is the big advantage is fast production. It is a lot of times way faster than milling something like stainless steel. You can just print something, put it in the oven, and then we have an object out of it. Materials variety. With one machine you can print a lot of materials. If you want to do that with a milling machine, you cannot print something with a milling machine. So it's really interesting. Like a normal 3D printer, you have for your desktop for like 200-300 euros. You need to make a lot of times support structures in order for your print to hold while printing. With a 3D printer, you don't need support structures because everything is already in the powder. It's also really cost efficient. So the disadvantages are with a lot of materials, parts are really weak. It's called, after printing, green strength. For some parts you need post-processing. So that means for stone-like material, for example, you need to put it in water afterwards. So the water will harden it because it works like concrete. For wood, you need, for example, a filtration process of sealer that also takes 1 or 2 days, so that sometimes might need, it's not very nice to have. The surface finish can also be rough. So for example, with stone-like materials, what you see is that x-axis and a y-axis. We'll show you that later. So the first step what we do is we put an STL file, 3D model in the software. Then we slice it, set the parameters, and then it's ready to print. So what it does, what you see here is you have two outer beds. This is what we call z-axis 1, z-axis 2. This is the bed where you put all the powder in. This is the bed where you print. So what happens is, once you start printing, the feed bed goes up and the outer bed goes down because it's going to spread. Like you see here, it goes up, then it rolls another layer. It's normally about 0 to 210 micrometers. So as you can see here, then it jets, so it goes up, it spreads one layer of 210 micrometers, then it jets an image, and it repeats the step again and again, and then in the end, you will get an object out of it. This is also something that we printed. This is a full process. So, for example, this is then the result of what we have and what we can do.
Who is she?
This is one of our machines. This is also the machine that we're having here. I will get more into detail in the next presentation. For now, there are some nice and interesting things to know about the fluid system. Like I said before, we print with binding jetting system, so we use two components. We have the liquid part, the glue part, and we have the powder part. Here is basically the schematic of the fluid supply. On the left side here, we have the waste binder. So what it does is, after we can set the amount, but after some layers, the fluid supply wants to jet out binder. It's basically a cleaning cycle. So the waste go into here. Here we have the binder storage. Here we put in the jerry can of the glue that we want, and then the fill pump will put it all the way through the energy chain to the ink supply, and then to the printer, on the prints. So this is the fluid supply. Here we have the fluid supply. Here we have the print head. And here we have the degas unit and this is pump. I will get into that a little later. So this seems like a lot, but it works quite easy. So here is the incoming binder. So the jerry can, if you go one slide back. So basically this binder goes into the reservoir, fluid supply. So what happens is we have the fluid supply works with two kinds of pressures. We have the meniscus pressure, meniscus pump, that is air, and we have the recirculation pump, that is here. So what the fluid supply does is it's currently in recirculation. It's always working like this. When the machine is doing nothing, it's also working in recirculation. It has to do so that there is a surface tension of binder in the print head. So it will not drip binder or it will not suck in air. And this is, for example, one layer that we jet. This is a 2D image that we jet from the top point of view. And this is then, for example, a stone-like material. This is what I mean with the surface can be a bit rough. Here you can also see the individual layers that we print. For example, here. So applications, 3D printing is an upcoming market. It's still a rough market, but there's a lot of room for applications. A lot of different industries want to experiment with 3D printing. For example, aerospace and automotive. Some clients are working with washout parts to make molds for motors or other systems. Architecture and construction. So what we see is that some clients really want to have a 3D printer for making models that they design because they want to make the model alive, and they think that stone-like materials is an interesting powder for them. Industrial manufacturing, SenseMos, like I said, aerospace, of course, for metal casting and tools. still interesting market. Consumer products and arts, figurines, decorative items, and art also have to do with architecture. But what we see is that a lot of artists come to us or come as a company, and they ask us to print one of their art projects. This is, for example, something a artist wanted to have for the lab with sunlight materials. This is one of the statues of Notre Dame. So the Notre Dame was on fire in 2019, and we as Concrete estimated we could deliver them 3 statues.
노틀담 성당이 예전에 불탔잖아요. 거기에 들어간 가골 석상을 페인팅을 해.
This is also one of the statues that one of our clients asked from us to do. This is multiple prints on top of each other, but then made with layers. So in the end, it's one full print. And this is for making a mold. This is one of the washout toolings as well. So this is gypsum. Well, what you can do with gypsum is you can put this part into sand or clay, and then make a hole, and then flush it with water. So then in the end you will get mold this out of it. And this is the Stelton project, one of our first biggest machines. We're currently working on another one. This is a very old machine, but as you can see here, this client is making multiple parts out of meters, I would say. This also stacks layer by layer upwards. Have you been there? Don't you do? You've been to Stockholm?
Yeah.
You know the stories.
저게 지금 아까 제가 말씀드린 ETHG에서 그 스위스 엠파라고 그 과학기술부 관련된 부서가 있어요. 걔네 건물을 걔네들의 그 스위스 학교들을 총동원해서 최신 기술로만 지어요. 근데 거기에 들어가는 이제 사운드 업솔션 그 슬래브 스트럭처에 저게 이제 그 사운드 업솔션 홀을 포함하고 있는 그 슬래브 몰드예요. 그래서 슬래브 몰드 제가 나중에 보여드릴게요. 보는 게 훨씬 더 빨리. 그걸 이제 저게 큰 이제 라지 포맷 3D 프린팅 기술을 이용을 해서 출력을 하고 저게 또 강도가 잘 나오기 때문에 그냥 그대로 써도 상관이 없는 거죠. 그거예요.
This is, for example, one of the results that they had. This was the small presentation for introduction. I do have another one to get more in depth for the technicians. I don't know if you want to do it separately or with other people with you.
지금부터는 이건 이제 그 마이너드 시스템에 대한 전체적인 오버뷰를 설명드렸고 지금부터는 이제 장비와 관련된 테크니컬한 부분을 설명을 드릴 거예요. 그래서 이 부분은 들으시는 게 좋긴 해요. 왜냐하면 이제 친구랑 예를 들어서 직접 뭔가 기술 개발을 하거나 이거 좀 설명이 좀 빠진 게 있는데 이 장비 같은 경우에는 어떻게 보면 되게 오픈소스 형태의 장비예요. 보통 대부분 프린팅 장비는 매티리얼을 바꿀 수가 없어요. 하지만 이 장비 같은 경우에는 우리가 원하는 성능을 갖춘 어떤 잉크라든가 레이어링 매티리얼들을 바꿔가면서 테스팅하고 그거의 레시피를 만들어낼 수 있는 장비예요. 사실상 이제 완전 랩 오리엔티드 머신이라고 보시면 돼요. 그래서 그런 부분들이 있어서 만약에 본인이 어떤 매티리얼이라든가 아니면은 뭐 어떤 제품을 개발하겠다든가 이런 계획과 내용들이 연구 테마가 잡히게 되면 아마 물론 저를 포함해서 요 테크니컬한 내용들 듣는 사람들은 본인이 직접 할 수 있게끔 유도하려고 하는 게 지금 이 다음 프레젠테이션의 목적입니다. 혹시 이해가 되시죠? 그럼 다들 이제 테크니컬 가이드가 되겠다고 생각하고 Please go ahead. Yeah.
You want to follow?
Yeah, everyone
Yes.
is okay to listen.
I think it's also good to combine the presentation with the machine itself, so we have a look together during the presentation.
Okay.
With the machine.
그리고 전체적으로 프레젠테이션 끝나면 제가 한번 바이너제 관련해서 다 설명을 드릴 수 있으니까 들으셨던 분은 안 들으셔도 되고 처음 듣는 사람은 들어도.
So now let's get a bit more in depth into our machine that we have, how it works. Before I did a small brief explanation of how the fluid supply works and how the spreading system works. So here we see the image that we see in the previous picture is the schematic of the fluid supply, waste binder and the fill pump. It's quite easy to write. You have actually, let's check here. We have here waste jerrycan. This is not a bottle, but just a jerrycan. We have here the jerrycan binder. If you look up, you see here filter. This is a filter for protecting the whole water supply. We have here the remote pump that is pumping the binder to the back, all the way to the system here. So, like I showed previously there, we did make a small change. This is called the meniscus pump. This is the pump that regulates the air in the system. So basically like a counter system for your window, so quick it will not leak, will not stay on one level. This is now the fluid supply. Here we have the filter and the small pump. Here you see the most of the pump, meniscus pump, which is in a different place, and the 5 micrometer inlet filter. Like I showed you guys in the previous presentation, this is the fluid supply. I'll get a bit more in depth into it. Here comes the liner from the jerrycan to the extractor. What this does is this goes through here to the reservoir. Then we have here the degas unit. This unit is an air filter system that goes and is connected towards this thing. It will basically suck out all the air that your system generates. And this is called the recirculation pump. Like I showed you before, the whole system recirculates through here. This is your inlet and the filter, this is your outlet. And during printing and during idle, your system just keeps moving through these tubes here and here. So your system stays activated and is ready to use always when it's changed. This is also a schematic that we have here. Here we have the printhead. Here we have the degas pump and also the meniscus pump. Here is the binder storage. So here. So, like I said before with recirculation, your system always rotates through these tubes. I'll show you later during the software analysis and what we can do if something issues come up. So this is a schematic drawing. Again, this is recirculation. Like you can see, these two are the valves that regulates the fluid supply. And here's the meniscus pump that puts air pressure inside the reservoir. We have here this chest filter. It's an extra filter for the printhead. Actually, how to wear it, and we said every 3 months to change the chest filter. So, ink supply regulates the required pressure for printing. So what it does is it's maintaining a stable pressure for printing. That has to do with the setting of the recirculation pump and the emissions pump. Depending on the binder you're using, you want specific settings because the binder, the glue, has a different viscosity level. So depending on the level, you either want, for example, a higher recirculation or lower recirculation. This is the waveform. Every printhead and binder uses a different waveform, also with speed. So depending on the material you use and the binder you use different waveforms. Waveforms is basically a pulse that your printhead will give to the binder, so it knows how big your particles should be, your droplet sizes from that specific waveform. I think we can get into this together later on. So this is the surface station. This is the station where this is basically the home of the inkjet. So everything, when it's in idle or when we need to flush out the remaining binder, we go back to this station. So during a printing cycle, you have after every layers that you want to purge out and flush out your printhead for a few seconds. So what it does here, it stands on top of it and it purges, and then it goes through the waste jerrycan. This cycles every 5 to 10 layers. So the capping station. The capping station is a new feature that we have. It's older. What it does is, if the machine is finished printing, you can use the capping station to avoid your printhead from drying. Also, it prevents the printhead from getting dust on. So if you're lathering, it's always good to use the capping station since there are always dust particles flying everywhere. So it's a safer usage for printhead. So loading powder. Loading powder is an interesting process. It still has to be done manually. On the left box that we have is called the box. You have to load powder in manually from a bucket or a bag. It's very important that we use a compress tool. So once we load in powder, we want to compress the powder. Otherwise, you notice that during the spreading sequence, it will not reach the end of the bed. And that can cause for issues during the print. If you have a very big print, you see that it's not homogeneously anymore in the bed. We will work with this also later in the print. So here you see load around 5 millimeters next to the walls for some materials. I might even recommend 1 centimeter from the bed. But for some, it should be fine. Just to be sure, I'll give it a bit more margin. Spreading, we come to it later during machine journey. So before the printing sequence, what we want to do is we want to clean the printhead. So if the machine has to be used for a few days, it's always good to first purge on top of the surface station, so get the whole liner out, and then clean the printhead with the dust-free wipes and demi water, demineralized water, or tap water is also fine, but not preferred. this is optional. We also have a sealant concrete. It's basically some sort of silicate that we have. What it does, it crystallizes concrete from the inside, so it hardens out a lot. It's optional. It is mainly used for outside if you want to put your prints outside. It's a bit more weather resistant. For inside products, not needed. Outside, it's recommended, but also not necessarily needed. Design guidelines, I will forward this. Are there any questions regarding to how the system works, about energetic?
The question is that, do you change the materials, or just keep the particle size unchanged? As long as the system is blocked.
So we can change this system with multiple materials.
For example, in concrete,
Yeah.
I can change the liner,
Yeah.
and I can tell the liner or the liquid. I
Yes.
can change the liner.
Okay. But keep in mind when you change binder, I will forward this extra information as well to Dr. Yo. Some binders are not compatible with each other. So for example, now there's an aqueous-based binder in the system, which is built on water. But if you put an alcoholic binder with different components into there and you put it immediately afterwards in the system, your system can clog. So we made this compatibility guideline to see which binders are compatible with each other. So if you would use a different binder or make the binder yourself, I'll say it's best to contact us, Ali, and you have to look together so we know which flush you can use before using your own binder. And keep in mind, when you use your own binder, always replace filters beforehand. So it is possible.
Thank you.
For additional, if you want to change the binding, it is totally depend on the inkjet specification. So there are a lot of binding system like I say epoxy or etc. So but they have a different type of viscosity and as you know, and we need to sometimes we need to use the solvent, different solvents. So we have to check the compatibility, and we have to ask them as to vendor. Yeah, it's okay. Yeah.
Also, it's very important. There's one step that I forgot to tell you. If you want to use your own binder, it's the waveform making. So I showed you previously. I don't know if I can find it now, but waveform is the pulse that your printhead gives. So depending on the viscosity of your new binder that you make, you want either a smaller pulse, bigger pulse, wider pulse, or multiple pulses. So making a new waveform also. So for making a new waveform, it's also important to know how to make waveforms, which is not really my place to explain it, but Farid can help you with that. It will take some time. So it's better to test yourself.
He said the waveform is stand for the determine to drone size and drone shape and speed and penetration depth. And this is very important to ensure the printing quality and material property. So we have to, if you want to change your own fluid system, you have to step by step making the right or best lesson. Do you understand? Right?
Yes, that's correct.
Okay.
Does someone have any other questions?
Is that the surface could be
Roughly.
is there any method to make the object surface make comfortable?
80 micron, your layers are smaller. If your layers are smaller, it means you have more layers, so it's less rough. But also you have to keep in mind that changing your layer height can also result in your prints being less effective, because the waveform, the pulse, the droplet size is also made, we designed it on the layer height, because the penetration of the droplets inside the powder will have also an effect. So if your layers are less thick, so from 210 to 180, there is more penetration in the layer, so you have a wetter print which can have an effect on your print. But for stone, I would recommend sandpaper.
You said the printer has like differentiating right, layer thin or thick.
Sorry?
The printer has magnetic position right. The layer is thin or thick.
The layer?
Very thick. Yeah. So the layer is thin layer or thick layer, right?
Yeah, you can choose. But we do have technical data sheets per material, which already give you the perfect solution for your printing. So the parameters, which waveform you need to use, and speed. So technically with stone-like materials that we have here, you don't need to experiment because we already have all the parameters for you.
이미 파라미터들이 좀 나와 있어요. 그래서 기본적으로 제공되는 소수별 파라미터들을 그대로 쓰는 게 일단 현재로서는 가장 품질이 좋은 그 출력 결과를 얻을 수 있는 거고, 만약에 우리가 뭔가를 바꾸고 뭔가 속도를 좀 빨리 하겠다 그렇게 했을 때는 우리가 프린팅 속도라든가 레이어 thickness라든가 아니면 피딩 스피드라든가 뭐 여러 가지들을 전부 다 조절을 할 수가 있어요. 근데 그렇게 해야 될 이유와 내용들이 명확해야 기존 파라미터를 바꾸는 이유가 나오는 거예요. 그래서 만약에 보통 이제 지금 어느 정도 메이처된 그 레시피를 바꾸는 것보다는 뭔가 새로운 접근법을 이용하는 게 좋죠. 예를 들어서 우리가 리퀴드 시스템하고 예를 들어서 바인딩 시스템도 바꾼다. 레이어링 매트릭 시스템도 동시에 바꾸게 되면 변수가 멀티플로 늘어나는 거예요. 그죠? 만약에 우리가 레이어링 매트리얼을 바꾸기가 쉽거든. 왜냐면 그냥 퍼서 다른 소재로 집어넣으면 되니까. 리퀴드 시스템을 그러니까 바인딩 시스템을 그대로 유지하고 만약에 레이어링 매트리얼의 조성, 컴포지션을 조금씩 바꾸면 예를 들어서 여기에다가 뭐 칼사이트라든가 뭐 칼슘계의 어떤 물질을 조금 더 배합을 해서 넣게 되면 하이드레이션이 되게 빨라지기 때문에 조경화된 어떤 구조물을 만들 수 있을 수도 있다. 그러니까 여러 가지 아니면 뭐 반대로 이제 바인딩 시스템에다가 뭐 바인딩에 영향을 주지 않는 어떤 케미컬, 예를 들어서 뭐 PCM이라든가 여러 가지 어떤 상변화 물질이라든가 아니면 타이타늄 다이옥사이드라든가 이런 것들을 같이 이제 섞어갖고 출력을 하게 되면 우리가 만든 출력물이 예를 들어서 광충류 효과를 낸다든지 아니면 열을 덜 받는다든지 또는 더 받는다든지 이런 것들을 우리가 물질적으로 유도해낼 수 있는 게 어떤 이 시스템의 장점이라고 보시면 될 것 같아요. 이해하셨어요? 오케이.
Someone else have questions? Shall we continue to the software?
Software?
Yeah.
Yes, please. 다음은 이제 소프트웨어 관련된 설명입니다. 장비 쪽으로 가셔서 보시면 되세요. 안에 들어가셔도 돼요.
So, yesterday we and Dr. Yo did already a print. The print is now finished inside the powdering bed. Quite curious how it ended up. But our software has a few features. that means that for this binder, we use 34 millibar and 50 millibar since with these two settings, there's a good balance in your printhead, so there is no air coming in from your printhead, and there is no binder coming out of your printhead. And here we have the powder. As we see here, we have the layer height and feed height. I accept it fully. The layer height is the height that we print in the layers of our final product. The feed height is the amount of powder that we want to put on the print pad. We can also create our own profiles. So, for example, if we click on copy, then we have here the ability to generate our own material. A lot of people also use their own material. They need, of course, different parameters. I can start for now. And then you see here the spread speed. So this is the speed that this part, the roller, rotates and goes over the print and feed pad. The layer height and feed height, like I said before, the layer that you want to print in, and the feed height is the amount of powder that you want to spread on the other bed. Offset height, this is a bit more advanced. Once you finish one layer of jetting, the z-axis go down, and the amount that goes down is 500 microns, half a millimeter. Depending on the material that you use, some materials bounce back. So after you spread with your roller, some materials will go back up. So for example, wood goes back up by a lot. So when you spread, it goes back up a lot. So then when you want to go back, it actually destroys your print. So for the offset height, you want to put it lower than the first row, you don't have to. Here we have roller speed. This is the speed that you want your roller to rotate. Depending on the material and the smoothness of your surface, for that material you might want to change it. For this material, we put it on 50. And this is also the IR heater. The IR heater heats up the bed before jetting. There's basically like a heat bulb inside. And when you do the spreading, it heats up the bed. So the penetration is a bit smoother, and also it evaporates the previous binder a bit, so it hardens your product a lot more. For this we have some settings as well. So this is the speed that we want our IR heater to go over the bed. We can either put it very slow, or we can put it very fast. There's a balance in here. This is also in the technical data sheet. If you put it too slow, it will basically destroy your bed because it evaporates everything. And if you put it too fast, it will not have too much effect on there. But for binder as well, you can also generate your own profiles for binder. If you want to design your own binder and test it, we have here the option to do so. So here we have the X and Y speed. The X and Y axis are basically this one. So this is the X movement, and the picture box is this is the X movement, and this is the Y movement. And then these two are Z1 and Z2. We can choose the speed that they have to print in. Also for this binder and this powder, it's already correct. That we can either print faster or slower. For some waveforms and some materials you want to print slower, but for solid materials we can print quite fast. Here we also have the option to change meniscus and recirculation pressure, fluid or temperature. Inside the reservoir there's a small temperature meter where you can heat up your reservoir.
Can you change fluid temperature?
Yeah, you can.
Good.
But for mineral binder we put it on 30. But we do notice that environment temperature also have impact on the viscosity of the binder.
Yeah.
I'll say this is fine, but if it's as warm as outside in here, then the viscosity of course changes, and then you notice that your circulation sucks in way too much air. So if that happens, just let us know and we will help you with it. I will also explain to you later on one-on-one how we can tweak settings.
Okay.
For example, if you notice that a lot of air in your system comes, it means that your circulation is too high. So when you see that there is a lot of air in your system coming in, you can see it from this tube. This is your outlet. So the outlet tube is if you think back about the recirculation, then you know that the recirculation goes like this. So that means that if your circulation is too high,
They can see.
oh, sorry. So if your recirculation goes like this, and if the recirculation pressure in millibars is too high, air comes in from the nozzles with your printhead, and then you see bubbles. So what you want to do, if you see air, you want to reduce the millibars of the recirculation by 1 each time until you don't see bubbles anymore. Same for if your printhead is leaking, that means that your meniscus pressure is too high. So you want to lower your meniscus pressure. And this is the cleaning period that I talked about. So after 5 layers, your printhead go back to here, to the service station, and it purges out for a few seconds to clean nozzle plate for excess powder and binders. So this is our slicer. Here we can put in STL files. Can I show you this? Yeah. So this is a test STL file from Dr. Yo. This is what we want to print today, right? If you can solve it, maybe I can maybe fix it. Here we can put in our STL file as how we want. We can move it by clicking on move and then selecting the arrows. We can also rotate it in any direction. And we can also upscale it. As you can see, it will show a red sign if you are over the boundaries. But there are also some hotkeys that can help you for faster making use of your modeling software. So, for example, we see here rotate model. If I click there, then it automatically goes to the rotate tab, and I can rotate it. Doesn't work. I don't know why. So we can also add multiple slices next to each other. So I think if I do this, if we go back, we can just select another one. We can put another one in. So once this is finished, and you selected your material settings, this is very important for starting your print. For example, if we create here a new profile and the layer height is different, so the layer height is 280, so that is 70 micrometer more, your slicing profile will actually use this one. So always choose the correct powder profile once you are gonna slice your part. Once your part is finished with slicing, you can click on the home screen, project, and you can already click on your folder that you've made, so the slice. So once you prepare it, it stores in here. So always do a logical name for you, otherwise you will forget it. So once that is finished, we can check first the settings. So, I forgot to mention that once you start up the machine and you start up the software automatically connects. So, here you see machine status ready, but it can also be unready. So, if you start up the machine and you start up the software, you have to wait around 30 seconds because the computer inside the machine, PLC, has a delay of 30 seconds that we set. So, once it goes from unready to ready, you're able to use it. Also, every time when you start up the machine, your motors needs to home. So there's a calibration. You want to home all positions before you're able to use it. So if you start up the machine, you start up the software, you see that it is in red, not ready. So how can you make it ready? Make sure that all the doors are closed, because there are door sensors in the doors, the yellow things next to the doors are door sensors. The machine will not work if the door is open. And then you will home every axis for calibration, and then you see that slowly, one by one, they will get ready, and your machine is ready to use. So let's do some motions. There's already a print in the machine, so I will not will avoid destroying it. I'll just give you some examples of what it does.
Why don't we depowder?
You want to deploy? You want to do
If
that?
you can.
Yeah. Okay, let's depowder now. So what I'm doing now is I'm moving the z-axis. This is z-axis 1, the left side. This is z-axis 2. So I'm now moving up the print side. So
어제 밤에 테스트 프린팅을 한 거예요. 그래서 지금 이제 원래 계획은 프린팅하는 것도 다 할 거고, 그런데 이제 어제 출력한 걸 이제 오늘 디파우더링 해보자. 그래서 디파우더링 하면은 이게 어떤 출력물 어떻게 출력이 되고 디파우더링 어떻게 하는지 먼저 보면 결과물을 먼저 볼 수 있으니까 이해가 더 빨리 될 것 같아갖고 제가 살짝 푸시를 한 겁니다. As you guys already know that this machine use power system because you have to prevent the inhaled powder. Yeah. As you well know, the powder composition is concrete and etc. Aggregate, etc. So you have to protect, inhaled powder. So
yes. It is safe. It is safe, but always working with powder, it's better to use a mask just for your own protection, because it can cause irritations, and you don't want it, of course.
그렇게 위험하진 않아요. 마셔도 괜찮은데 우리 시멘트도 많이 마시잖아요, 그렇지? 그래서 여기 지금 디파우더링 하는 과정들을 가까이서 보세요. 가까이서 보셔도 돼요. 왜 겁나? 내가 먼저 볼게. 궁금해요.
What I'm doing here is I'm powdering it inside the waste, because we can still reuse this powder, of course, if we collect it later.
오른쪽으로 떨어지면은 밑에 이제 리턴되는 그 캔이 있어요. 그래서 이 파우더들은 그러니까 언바인딩된 파우더들은 전부 다 리유저블한 파우더가 되는 거예요. 다시 쓸 수 있어요. 지금 사용한 소재는 여러 가지 소재가 있고 뭐 라임스톤 뭐 등등등 뭐 마블스톤 등등등 있는데 이번에는 콘크리트랑 같이 협의를 해서 콘크리트 파우더예요. 그래서 조금 더 강도가 좋게 나오는 파우더 시스템을 좀 많이 파우더를 많이 사왔습니다. 그래서 그걸로 먼저 테스트를 해보고 뭐 라임스톤이라든가 그래나이트라든가 마블스톤 같은 경우에는 소재의 조성은 다 같은데 색깔이 달라.
So okay, here you can still see like what happens if you see these layers. It was because we did your print first that didn't work. So if you print too close to your previous print, it will, as you can see, it will stick to it.
Okay,
So
I
we
understand.
Get it out, but always make sure to spread like multiple times before you do another print if it fails.
Yeah.
This is a good example. You see the layers here.
Oh, yeah. We did add the 5 or 6 layer, right?
It should. I think we should do 10.
Yeah, it seems like it's not enough.
Yeah.
Yeah. 어제 출력을 하다가 1차 출력물을 제가 모델링한 건데 그 모델링이 그 슬라이싱 되면서 에러가 났어요. 그러니까 모델이 안 좋다는 얘기예요. 보통 슬라이싱을 하다가 에러가 나면 대부분 그 모델이 뭐 스텝이나 3DM 파일에서 STL로 전환되면서 면이 터졌다는 얘기예요. 그 STL 파일이라는 거는 그 스테레오 리소그래피 약자인데 이 3차원 입체를 물 안에 넣으면 물과 객체의 경계값만 뽑는 거예요. 그걸 기반으로 최외곽선을 만들고 그게 안에가 솔리드냐 아니면은 뭐 보이드냐 이런 것들만 결정하면 되는데 설계를 했는데 면이 터지면 이게 입체로 인식을 못 하잖아요. 그 과정이 한번 있어서 그걸 취소하고 거기 위에다가 5개의 레이어를 추가하고 그 다음에 새로운 오브젝트를 올려서 출력을 했더니 5개의 레이어는 지금 한 레이어가 거의 한 200에서 250 미크론이에요. 그러면 5개라고 해봐야 얼마야? 2mm 정도밖에 안 되는 거예요. 그죠? 그러니까 이게 서로 너무 가까워서 서로 붙은 거예요. 바인딩이 되는 거예요. 그래서 이렇게 뒷부분에 이렇게 오돌토돌한 게 생긴 거고, 이 앞부분은 정상이에요. 이게 아무래도 그 디파우더링 하면서 이제 분진이 날리기 때문에 저기에 이제 선풍기 2개를 둔 거고, 예산이 좀 허락이 된다고 하면 저희가 그 베큐um 클리너를 살 거예요. 그래서 그걸 가지고 쭉 빨아들이고 거기서 이제 회수된 파우더들을 다시 여기 통 안에 넣어서 사용할 수 있습니다.
This powder is a bit more industrial, the stone concrete powder.
Yeah.
So the powdering is a bit rougher. But it's in general harder than the limestone and granite and marble that we have.
Yeah.
If you want to do the marble and granite today, one of those two, it's a lot easier for the powdering. This really takes time. The green strength is a lot harder. As you can see here, you see the layers of the print that we did at the start. Just stuck
Yeah.
with it.
그래서 프린팅하고 디파우더링 하는 방법과 내용까지 여러분들이 아셔야 직접적으로 본인이 이렇게 실제로 해보고 할 수 있어요. 네. 그래서 제가 이걸 보여주자라고 얘기를 한 겁니다.
For now, I think this is good enough. It's not fully depowdered yet, but I also broke some stuff, but this is in the end result. This is still quite rough, but the best thing actually I do recommend is spraying it with a compressor. Because if you use a compressor and with stone-like materials, it will not break. It's a lot better, and for example here you see like the holes.
Yeah.
And also here on the side, you can really open them up, and with a brush it's a lot harder. But doing that, I do recommend something like the powdering station, or at least a box or enclosure where you cannot spray the whole compartment with the powder. Don't touch it. Safe.
Safe. Totally safe. Don't worry about that. Just the concrete. 이 프린팅 장비를 잘 쓴다는 거는 이 프린팅 장비가 그 출력할 수 있는 한계를 잘 이해하고 그걸 기반으로 설계를 하는 거예요. 그래서 지금 예를 들어서 초정밀한 어떤 프린팅 장비랑은 조금 맥이 달라요, 저는. 저런 류의 각진 형태를 만들기보다는 저기 뒤에 보시는 것처럼 뭔가 라운드하고 비정형에 가까운 어떤 곡선을 가지고 있는 제품들이 훨씬 더 출력이 잘 되는 겁니다.
So for making structures and bigger 3D models, I would recommend using this powder. But if we want finer details, also easier the powdering, I would recommend you using the bags. The granite and limestone and marble, I don't know which one of the three you have. Two. Those are a lot easier to powder as well. Better for finer details. In general, this one is a lot stronger too. So that's for the powdering.
Okay, let's go back to
Yes.
Yeah.
I will do now some motions.
Oh yeah. Why don't we break? Why don't we break?
Break? A break? Yeah.
Yeah. It's okay?
Yeah, of course.
좀 쉬는 게 좋을 것 같아서 잠깐 쉬겠습니다.